So in this video here, we're going to be solving exponential equations. In the previous video, we were graphing the functions for exponentials. In this video, we're going to be looking at equations that have bases where the exponent is an x, and you have to try to get x by itself and solve it. And the way you do this is to make sure if you want to get the exponentials, you have to make sure to cancel out the bases. To cancel out bases, they have to be the same first. So a lot of the times when people are solving for exponential equations, they'll change the bases first. So they'll change the base so that they are the same. And this is not always possible to do, but this is one method that usually will be something you start off with. And if it doesn't work, we'll do something else. Now, for this problem here, it becomes really clear. If we're solving for x, we can see that both sides have a base of 7. So if they both have the same base, kudos for you, you can cancel that base out. So I can cancel out these 7s because both sides have a 7, so I can cancel them. So x comes down, and then 3x minus 6 comes down. So basically, the exponents get to come down. Now, from here, it just becomes like a normal type of equation that I'm solving. My goal is to try to get x by itself. So maybe I'll try to get all the x's on one side. So perhaps I'll subtract 3x off of this side to cancel out that piece. So then let's see, 1x minus 3x is negative 2x. And then this side is a negative 6 that drops down. So then I'll divide off a negative 2, and my x here is equal to, let's see, negative 6 divided by negative 2 is a positive 3, so my x is equal to a positive 3. All right, so I found my solution, and there we go. So I just have to make sure that the bases are the same to cancel out, and then I get to the exponents to solve. The only issue is that when I run into a case where the bases are not the same. So 9 and 81 don't have the same base, but here's the thing. Sometimes you can manipulate one or both to end up looking at having the same base. So if we think about it, 9 is a smaller number. Can 81 have a base of 9? That's the question. And yes, it can. You guys might recall that 89 or 81, sorry, not 89, 81 is also 9 squared. Like these two are the exact same thing. 9 squared is 81. And so this side is 9x. Because I've changed this to a 9 and that side's a 9, I get to cancel out the bases now. And so now I really have just an x that comes down and the 2 that comes down. So x equals 2. And turns out once I cancel out the bases, I get to my answer very quickly. So x equals 2. All right. This next one here gets tricky because this one's a fraction and this one's not. So it's like, how in the world am I going to make sure that these bases are the same? But if we think about it, both of these are even numbers. This one's a half, but we've learned that if something's in the denominator, you can make it, if it's in the denominator, it might have like a negative exponent. So I could possibly change this to 2 negative 1. So let me change this to 2 negative 1. And then the outside here is still an x. So this is an x. And then I've changed 1/2 to 2 negative 1 because these two would happen to be the same thing. If you have a negative exponent, it throws the base into the denominator to make the exponent a positive. So the question is, can this 4 have a base of 2? Because if it can, that's awesome. And it turns out it can. So 2 to the second power is equivalent to 4. So I've changed this 4 to a base of 2 now. So now since the base is the same, I can cancel the bases out, which is great. But keep in mind, there's an exponent here and this is an exponent, so they multiply. So just as a quick reminder, negative 1 and x will multiply to get negative x. And then the 2, this 2 here drops. So to get this x by itself, I need to move over this negative sign. And if you think of this like a negative 1, I would just divide off a negative 1. This would cancel. x comes down, and this is 2 divided by negative 1, which is negative 2. So my x here is equal to negative 2. So these two is what I really want you guys to practice on. So if that didn't make sense, maybe rewatch the video to see why and how I manipulated the bases. But usually, if the bases are not the same, you're going to have to do some manipulation. Sometimes it's just one side that gets manipulated. Sometimes it's both sides that gets manipulated. So it just depends, and we just need to be flexible with the numbers. All right, let's get to solving. So these here have just quite a variety of different exponential equations to solve. This one here has a 2 as a base and an 8. So start off with looking at the bases and seeing if you can manipulate them. So this 2 I probably can't manipulate, but this 8 I can manipulate. If you guys remember, 2 to the third power is equivalent to 8. If you don't believe me, just so use a calculator and see what you get when you do 2 to the third power, or 2 times 2 times 2. So I've changed the base for 8 so that I can make it look like the other side. So now that the bases are the same, they cancel. And so I really have a 5x minus 1 equals 3. And now this becomes easy to solve. I'll just add 1 to this side. That cancels. 5x comes down, and this becomes a 4. And then I need to divide by 5. And it looks like x is equal to 4 over 5. So you get a fraction as your answer, but that's okay. Sometimes we just have fractions. Or you can change that to a decimal, but I would keep it as a fraction. Less work for you. So this one here, just as a quick reminder, we change the bases, we cancel out the bases, and then we just solved. So pretty easy here. This one here, same thing. I have a 9 and a 27, so I have to think about changing the bases. Now, I know 9 times 3 is 27, but there's no way I can make this 27 a base of 9. Like 9 to the first power is 9, 9 to the second power is 81. It's too big. But both of these are divisible by 3, so I think 3 is the base here. 3 to the second power is 9, but there's an x here, so make sure you carry down the x. So I'll just put the x on the outside. Or you can just put, actually, you probably don't need parentheses. You could probably just put the x right there. So this is 9 is 3 to the second power, and then the x is just dropped down. And then 27, if we think about it, 3 times 3 is 9. 9 times another 3 is 27. So 3 to the third power gives us 27. And so now I can cancel out the bases since they're the same. So 2x equals 3. I would just divide off 2 to get x by itself. So x is equal to 3 over 2 is my final solution. All right, so that one I had to change both of the bases to find a common base that would work for both of them. And that might happen. So just be flexible with numbers. This one's really tricky. So this one you have an 8 and this side's a 1. And 1 doesn't ever become an 8. So 1 here is a smaller base, and 1 to any power is not going to give you 8. So this is the part where it's kind of a trick to remember. We need to remember that anything to the 0 power is 1. Okay, keep that in mind. So if this base here is 8, it might just be easier to make this side an 8 and raise it to the 0 power, because 8 to the 0 power is technically equivalent to 1. And so I'm going to change this to 8 to the 0 power, so that way I can make the same bases. Basically, anytime you have a 1, you get really lucky and you can make whatever the base you want, because any base to the 0 power is 1. And then I'll bring down the other side here. But notice now both sides have an 8 as a base, so they cancel. So now I have 4x minus 3 equals 0, and then I'll just solve. So maybe add the 3 over. 4x comes down. This side's a 3. I'll divide by 4. That cancels. And x is equal to 3 over 4 as my value. All right, moving on to the next problem here. This one's D, and this one gets a little bit tricky because we have to think about trying to get to this exponent, but there's a 12 outside of the parentheses. So when you're solving, you're thinking about trying to get to x, but sometimes you have to get rid of the outer layers first. So the thing that's furthest away from x is probably this 12. So in order to get rid of this 12 is multiplying the parentheses. So to undo it, I have to divide it off. So I have to divide off the other side. So then this is 10 to the x that drops down because the 12 is gotten rid of. 1200 divided by 12 ends up being 100. And so now I can clearly see that this is a 10 and this is a base of 100. But I know that 100 is really 10 squared. And so now the bases are the same and then they cancel. So x comes down and 2 comes down. And now x is already by itself. So x is equal to positive 2. And that was pretty quick. But the goal here is to notice that in order to get to x, sometimes you have stuff outside of it. And so you have to take the outer layers off until you get to the exponent. All right, this one here is tricky. So this one is a 7 and this is 1 over 49. Now I know 49 is 7 squared. Like I'm thinking to myself, 7 squared is 49. So I need to change this base to a 7 since it's kind of the bigger number here. So I'm thinking to myself, well, what if I think of it as 1 over 7 squared? And I'll bring down the other side just the way it looks. Now, if I think of this as 1 over 7 squared, then this is the exact same value since 7 squared is 49. But since this is in the denominator and I want to get it out of the denominator, I can say this is 7 to the negative 2 power, right? Because 7 to the negative 2 would throw the 7 in the denominator. Now, in most cases, I wouldn't want a negative exponent, but my goal is try to get the same base as the other side so I can cancel out the base. So now that the bases are the same, both sides are 7, I can cancel that out. And so 2x minus 6 comes down, and this negative 2 exponent comes down, and now I'm ready to solve. So I might add 6 to the other side. 2x comes down. This becomes negative 2 plus 6 is 4. I'm going to divide by 2. And x is equal to 4 divided by 2 is 2. And that is my final answer. I'm getting a lot of x equals 2 for my solutions here, but that's okay. All right, so this one here, just a little bit tricky because, you have an x, you have a fraction, and we have to think about making the same base, dealing with negative exponents, but take advantage of negative exponents because that'll allow you to be flexible with fractions. All right, last one but not least, this one here, I'd like to mention, notice how there are 3 5s here. So one of the things that students will do when they first see this problem is that if they notice that all of them have the same base, they'll want to cancel everything like this. But you can't do that because in order to cancel out bases, yes, they have to be the same base, but they also have to be all together. Like if there's 2 5s here, you can't cancel out with this side. So you have to combine these two first before you can cancel out the 5. But one of the things we've learned is if 2 things have the same base, you can combine them by adding the exponent. And just to kind of reiterate why that's the case, think about when you have an x, let's say this is x squared, and you multiply it by x to the third. Because they both have a base of x, you add the exponents. So 2 plus 3 is going to give us x to the 5th power. So same thing here. They both have the same exponent, or not the same exponent, the same base. So I'm going to take the 5, and I'm going to add the 3x with the negative x here. So I'm going to take this exponent and add it with this exponent because I'm multiplying 2 things that have the same base, so I add the exponents. And then I'm going to bring down the other side. So 3x plus negative x is just going to give me 2x. And now both bases are the same, and I just have 1 on each side. So now I get to cancel them. And so I have 2x that drops and negative 3x that drops. And I have to get all the x's to one side. So maybe I'll add 3x to this side. Oops, add 3x. That would cancel. So this would be a 0 on this side, and this would be a 5x. 2 plus 3 is 5. So I'll divide 5 off. That would cancel, and x is equal to 0. So it looks like here x is equal to 0 as my final answer. All right, so that was quite a few problems already. So in this lesson, we're talking about solving exponential equations, and the goal is pretty much to solve exponential equations. You try to make the bases the same so that way you can cancel out the bases and get to your exponents. If you want to practice more of these problems, try out the practice problems down below, and then feel free to check with the answer key to see if you're on the right track. All right, that's it for this video. Bye, guys.